In this video, we'll take a look at vertical and horizontal translations for the quadratic function. So in this investigation, we'll take a look at what is the relationship between the value of k in the equation y equals x squared plus k and the shape of the graph of the relation. So let's see. First we have y equals x squared as our basic function, and we are going to try and graph y equals x squared plus 2. So we input x squared plus 2 in Geometry Sketchpad, and we obtain the graph of the new function. We notice that the graph has shifted 2 units up along the y-axis. Now let's see if something similar happens if we choose a different number to add to x squared as the k value. So let's plot x squared minus 4. Let's see where this graph shifts on our graph. Well, we take a look and we see that the parabola of x squared minus 4 has shifted 4 units down when compared to x squared. So let's try x squared plus 5. Sure enough, this graph has been moved 1, 2, 3, 4, 5 units up along the y-axis. So what can we conclude from this is that if that value of k that's added to x squared is a positive number, the parabola or the graph shifts k units or the certain number of positive units up along the y-axis, and if the k value is negative, we shift the graph k units down. So in our case, the function x squared minus 4 shifted 4 units down. Now it's time to look at horizontal translation. Okay, so we see that if we add or subtract a number from x squared, the graph shifts vertically along the y-axis. What happens if we add or subtract a number from x? So let's try and graph x minus 4 squared. Let's see how that looks on the graph. Well, what do you notice? From the vertex 0, 0, the vertex of the new parabola became 4 and 0. But the equation is x minus 4 squared. So my graph just shifted to the right 4 units. I wonder what happens if we change the sign inside the bracket. So if we would have x plus 6 squared, where will that parabola shift? Well, sure enough, it shifted 6 units to the left. When the h value is a positive number, so I have x minus a positive number, my parabola shifts a certain number of units to the right, which means that every x value gets added h number of units. Now, if h is a negative value, meaning I have x minus negative 6, and the double negatives give us a positive, then my parabola shifts 6 units to the left, which means from every x value I'm subtracting 6 units to shift the entire parabola to the left. Let me clear the graph. Let's see what happens when we combine some of these transformations. Where do those functions move on the graph? We'll still leave the x squared function up on the graph so we can see it and always compare. But let's try something like this, where we combine a vertical and a horizontal translation. We would have x minus 4 squared plus 5. Well, I know that if I'm adding a positive number to x squared, my graph should shift 5 units up. And I know that if I'm subtracting a number, so if I have x minus 4, h means it's positive because it hasn't changed the sign within the bracket. So I'm shifting the parabola 4 units right. So I should be able to shift this entire parabola 4 units to the right and 5 units up. So it should start over here. Well, let's see if it does that. Sure enough, it does. So it shifted 4 units to the right and 5 units up. Let's try one more, where we have maybe x plus 5 squared minus 4. So again, I'm thinking my parabola should shift 5 units to the left and 4 units down. So with that being said, for sure my parabola shifted 5 units to the left and 4 units down. And you can see the transformations when they're combined now. So I'm moving away from the y-axis. We're not going to graph every single parabola along the y-axis. Things will start moving on our graph. Now if I'm thinking the vertex point of this last function is, if I'm reading right off the graph, is this point right here, -5 and -4. Well, let's see what the -5 corresponds to. It corresponds to the h value inside the bracket, where the -4 corresponds to the k value. In class, we'll formalize some of these concepts and add to them, as it's important to understand the relationship between a, h, and k, and what happens to a function as it's put through certain transformations.